the hour. This is always the interesting part when I start streaming to YouTube, then I hear my own voice 2 times, and that's really scary. But anyway, no, it looks like everything's going fine. So yeah, so you give a lot of talks. Do you ever, and also, okay, so interesting as well too, you know, Stack Overflow bought Pluralsight. So now you work for Stack Overflow, or how's that going to work?
No. I'm still in my company, where I used to work for last almost 5 years.
Yep.
And I'm also at Pluralsight. I'm also there as an author, creating courses on Azure and data stuff, things like that.
That's good. That's good. Well, no, just anyway, just when you see these things in the news that so and so is getting bought out, you're like, oh, I wonder what's going to change. And when did you start teaching in Pluralsight?
Last September.
Okay. And how's that been as an experience?
Yeah, that's an interesting experience because they have a pretty much standardized process for creating courses. So you don't have so much freedom. You are basically you're getting template for your course, and you are allowed to use specific set of colors, specific set of icons, things like that. And then of course you have your own creativity to present the content the way you want. But
I understand what you mean. They're going for very
visually.
Yeah, a sort of standardized procedure, which
Exactly.
in some ways simplifies it. And also when you have so many folks that are giving courses, you want to sort of be standard. But I also understand from a creative's perspective, you know, then you don't have as much freedom to use maybe some things that are a little bit funnier or things like that that kind of break up with that.
Exactly.
And have you ever taught in Serbia as well?
No.
You should. You should hire you. You're the data Mozarts. You're a big deal. That's cool. I haven't found a second data Mozart. Did you tell me that there was a data Beethoven, or there was something?
I don't know.
Okay, maybe I was making that up. I was making that up.
Recently, Ginger from I was presenting at Data Saturday Southwest US. Ginger Grant asked me, why is data Mozart? Am I a fan of classic music? I said no. And then I explained it was because of Salzburg. Not with classic music.
It's a fair reason to start. But you know, because you could also be a prodigious, you are a data composer. You can think, I like to think is like, I always like to do that in these meetups as well. And I'll probably do this later when we get to the end about football, since you know so much about football. Is, you know, it's always fun to relate things that you do in your free time to the stuff that you do at work. Also, particularly because when you work on things as technical as what you're doing, working with data on Azure cloud, you know, and we're talking about Kubernetes in our community, these things often get very complex. And so sometimes if you have to talk to friends or family and they ask you, what do you do? You know, I was in California for 4 weeks and all these people, so what do you do? I was like, I run a community that's focused on a very specific technology and it's complicated. So we get together and we talk about it. Like that's generally how I try to explain it. And they're like, so what's the technology? And I'm like, don't worry about it.
You don't want to know.
Actually, they even asked me yesterday in the airport when I was going through customs in Lisbon. They were like, "Oh, so what do you do in Spain?" I was like, "Well, they're like, what's your job?" I was like, "How much time do we have?" You know, but so I just say I work in technology. It makes it simple.
Enough. Yeah.
It's enough. It's enough. All right,
keep it simple. Yeah. Keep it
simple and don't make other, because then they'll be like, "Oh, so it's the cloud?" I was like, "Well, yeah, but there's some other stuff." And then as well as it, when you start taking it to trying to explain things like the CNCF, Cloud Native Computing Foundation, the landscape with all these companies and all these logos and all these open source projects, and then explain the difference between Sandbox and Graduate. Anyway, it gets very complex really quickly. But that's kind of why we're here, is to make these things simpler, to make these spaces more accessible so that more folks can get involved.
Exactly, yeah.
That being said, we are at the hour, so I want to do a more formal introduction. Welcome everyone to meetup number 56. We've done more than 56 meetups actually, because we're not including ones we've done in other languages. I learned a little bit of Serbian before this meetup. I'm going to try it again to say hello, zdravo. Kind of get it because the Z runs.
Hola, perfect, hola.
Okay.
Hola.
And I'm with a Spanish speaker and a Serbian speaker, who is Nikola Ilic. I think I said that correctly. Good. Surnames can be tricky. But anyway, very, very nice to have you here. He is also known as the Data Mozart. We'll be putting the link on the YouTube comments. Just quick explanation about the YouTube comments. If you have questions, ask them. All right. Nikola is a legitimate trainer with Pluralsight. He's been with there for almost a year. This is the fourth talk he's given in the last 5 days. We were just talking about that. Very active, very accessible, extremely friendly, showing wonderful Balkan hospitality, if I can call it that. But anyway, it's a lot of really, really good vibes. Very nice to have you with us today. Nikola, how's it going?
Yeah, it's going great, and thanks for this, for your kind words and this nice introduction. Yeah, it's always nice to hear. Thanks, good. And thanks for having me, and thanks for inviting me. It's a really pleasure to present for Data on Kubernetes community. Yeah.
Perfect. That being said, tell us a little bit about yourself. How did you first start encountering data? Tell us some fun facts about Serbia that we might not know. Tell us everything.
Yeah, there are no fun facts about Serbia. Just kidding. Yeah, there are a lot of them. So yeah, we will need an additional session only for fun facts.
That's good.
Serbian, yeah. So yes, I started in working with data like, I don't know, maybe 13, 14 years ago. Okay. It was good old Excel. Then I learned SQL along the way, started with relational databases, and that's basically my background. So on-prem databases, 90% of my career was related to Microsoft solutions. So SQL Server, reporting services, integration services, analysis services, multidimensional, building cubes, things like that. So regular BI stack from Microsoft. And I spent a little time working with Oracle and MicroStrategy as BI tool. And last 4 or 5 years, I'm more focused on building reporting solutions using PowerBI predominantly. So that's my main area of working today.
Okay, with that in mind, and also just because earlier today I was listening to the Kubernetes podcast from Google, and they were talking about there is a debate about GitOps, and someone wrote an article. I don't know exactly who. I'll have to find it. Basically dismantling it and saying there is nothing new here. These are things that have been done for a long period of time. They're just being repackaged and rebranded as something else. Now, we don't need to go down that road specifically, but just as someone who does have a lot of experience, looking at how data is being handled nowadays, once again, our community, we're talking about data on Kubernetes, but just thinking about databases, you mentioned relational, non-relational databases. We've got SQL, we've got NoSQL, we've got all the different options that are out there. There are some pretty heavy debates out there. DBAs, folks that work with data can be, we can say, pretty hard or sometimes pretty sensitive about which things they prefer to work with. My question is, considering your experience, how we handle data, how you handle data, how you worked with it when you started, and how it's being done now, what for you would you say are the major changes? Have there been as many changes as we might like to think? What would you say about that?
Yeah, I'll touch that during the session. Shortly said. I mean, now the difference comparing to like 6 or 7 years ago is that we have a lot more of data sources, different data sources. So for example, we are capturing data coming from different sensors, IoT devices, things like that. So more like different flavors of data. And consequentially, when you're capturing all this stuff, you have a huge amount of data, like not like previously when you had like normal transactions or from retail system or something like that. Now, if you're capturing really big data, those are really petabytes it scales to petabytes. So from my perspective, in the last few years, amount of data drastically changed, and different, I call them flavors of data. So different data sources. It's not just coming from relational structures, though they're coming from literally everything you can imagine that can capture some kind of information.
This is a very good point. Like you said, we're talking about size and also the sources. Sources can also then affect data quality, but anyway, we can probably get into these things a little bit later. That being said, show us your presentation. Once again, to folks that are in the audience, put your questions in YouTube. If not, we will continue the conversation in Slack if we can't get to everything. I've got a couple of questions as well, but we'll get into that after the presentation or during the presentation. So Nikola, if you want to share your screen, go for it.
Sure, thanks, Bart.
Okay.
Let's start. Hopefully you can see my screen now.
Yep, we're all good.
Perfect. Yeah. So hi again, everybody. Good evening, because it's evening in Austria. Good evening or good afternoon, depending on which part of the world you currently are. And as I said, I'm really excited to be with all of you here, virtually, of course, and chat about technologies and products I truly adore. So today we will talk about Azure Synapse Analytics, or to be more specific, about Serverless SQL pool within Synapse Analytics. And before we dive into a real fun, I just want to give a credit for this part of the session title. It's just a SQL. As far as I know, that belongs to Microsoft's Anna Hoffman, who famously said that maybe a year or two ago when she was asked to explain the difference between on-prem SQL Server and Azure SQL database. And she said it's just a SQL. So basically it's same thing, yeah. So, and I thought it completely makes sense to use this sentence as part of the session title, as probably a lot of you are now asking yourself, what is the difference between SQL Server and Serverless SQL pool? So don't be afraid, as title suggests, it's just a SQL. So make yourself comfortable and yeah, grab a coffee or some other refreshment, as yeah, we will kick off very soon. Bart did a nice intro. I will not waste too much time. Just short few sentences about me. I'm originally from Belgrade in Serbia, but for the last 5 years I live in the beautiful city of Salzburg in Austria, where I work as a business intelligence developer at company ITSP services. Living in Salzburg was the reason why I've chosen my nickname Data Mozart. I guess you all know that Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart, and here everything is in sign of this great composer. So I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. You can find me on web. I'm regularly blogging at data-mozart.com. I'm also pretty active on LinkedIn and Twitter. So yeah, feel free to ping me or connect if you like. Other than that, I'm father of 2 kids and true football and Barca fan, as you can conclude looking at the photo on your screens. Since recently, I'm also data platform MVP and from previous year, Microsoft certified trainer. Okay, so I will briefly walk you through the contents of our today's presentation. We will start with quick comparison between traditional and modern data warehousing concepts in order to put our discussion in the proper context. Then I will try to introduce you with Azure Synapse Analytics and core components of this platform, which will enable us to better understand the next unit. What is a serverless SQL pool? Why should you consider it for your analytical workloads? And finally, in which scenarios would it make sense to go this way? We will then go and examine different techniques of using T-SQL to retrieve the data from semi-structured and non-structured sources, such as CSV or Parquet files, for example, or even NoSQL databases like Cosmos DB. And in this part, we will see which tools we as SQL developers have under our belts when dealing with those challenges. Straight after that, I will cover the best practices for using Synapse Serverless SQL pool and how to get maximum from this engine. Last but not least, as I'm sure that most of you folks are interested to hear how much this costs, we will talk about pricing, what counts for the billing, and how to manage your costs. Also, finally, how to try to save money in your wallets. There will be a few short demos along the way, so you can get a better feeling of different features within Synapse Serverless SQL pool. Okay, so here we are. Once upon a time in a far, far away land, I'm just kidding, the story doesn't start like that, but the story starts with a quick look back to some concepts that were and still are omnipresent in the world of data. There are multiple ongoing discussions these days about the relevance of traditional data warehousing concepts in today's state of play. I will not go deep into these discussions. I just want to shortly express my belief that traditional data warehouse is far from being dead. I would say it's more in evolution phase, adapting to many new challenges that we mentioned before the session started. Those challenges are typical for large data volumes or different flavors of data sources, let's call it that way. So in a typical traditional data warehousing scenario, as you can see in this illustration, you would go and collect data from multiple different sources, perform some kind of transformations, data cleansing, stuff like that, before putting consolidated data into a relational data warehouse. This was and still is the focal point for your reporting solutions, a single source of truth for your data, and you could build various reports from there using a whole range of tools. If you're old enough like me, for example, Crystal reports or SQL Server reporting services or Power BI, if we are talking about Microsoft solutions, of course. You could also build an additional semantic layer using analysis services, both on premises or Azure Analysis Services, to create cubes, both tabular and multidimensional cubes, and then target those cubes with reporting tools, which I previously mentioned. And also don't forget good old Excel too as a reporting tool. And if you think of a traditional data warehouse, as its name suggests, like of a warehouse, you are close to truth. It is like a large store. And modern data warehouse is like an extra big distribution center. On this left picture, so in this traditional large store, products are already unpacked, prepared, they're ready for use. So it's like someone extracted them from the boxes, transformed their original package, and loaded the shelves in the store. I guess you recognize the analogy with ETL, extracting, transforming, and loading. So in this traditional way. And these products are ready for consuming. On the other hand, in this big distribution center, well, you see how the items are being stored there. But if I need immediately a box of, let's say, a beer or Coca-Cola, I can also pull it directly from here without needing to go to my local shop to take it from the shelf. So as you can see in this illustration, modern data warehouse accepts data from the whole range of different sources, structured sources, semi-structured, non-structured sources. This can be graph-like data from social networks, data streams from different devices, data from JSON documents, CSV files. So literally anything you can imagine what is capable of storing some kind of information. And now this big distribution center can keep the data in its original form, in its original package, without need to apply some additional steps in order to prepare this data for further analysis. So speaking in that regard, whole range of different data professionals can benefit of having a solution like this. For example, data analysts can use Power BI or similar reporting tools to create reports over this data, while, let's say, data scientists or machine learning engineers can create and train their models right away. The key concept here is that unifying experience that modern data warehouse provides. And that being said, there are multiple benefits that modern data warehouse provides. From technology perspective, modern data warehouse brings the following advantages. It is always, or let's say almost always available. Then it scales to extremely large amounts of data. It's also very flexible because you can quickly get insights from literally any data source, which in the end means that less time is needed for data movement and data preparation. And that brings us to reduced overall ownership costs when you have a solution like this. Let's now talk about Synapse Analytics as a modern data warehousing tool. So do you recognize the object you see on your screen? Yes, exactly. That's the famous Swiss knife. You can cut the paper, open a bottle of wine or beer, or you can even go and cut some smaller items, and all of that using one single tool. So if you are asking yourself now, what on earth does Swiss knife have in common with Azure Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data workload needs. And let me explain how. So do you need to import data from multiple different sources? Synapse can do that. Do you need to transform your data before serving it? Synapse can do that too. Do you need to store the data? Synapse can manage this for you. Do you need to query non-relational data or even files directly? Synapse can do that. Watch out now. Do you need to query non-relational data or files directly using plain old T-SQL? Synapse can do that too. What? I hear you say it again, Nikola, so I will say again. Yes, you can write T-SQL to query data from CSV, JSON, or Parquet files, but more on that in a few minutes. Do you need to build machine learning models? Synapse can manage them for you. So finally, do you need to create your Power BI report straight from the Synapse? Yes, that is also possible. So as you may conclude, Synapse is a one-stop service for all your data tasks. Or if someone asks you to define Azure Synapse in 3 words, you can freely tell that it's an end-to-end analytics solution. Fine, so here's the quick 10,000 feet high overview of different components that make Synapse Analytics integrated analytics solution. For SQL professionals, there are two pools in Synapse. Dedicated SQL pool, which is the official successor of former Azure SQL Data Warehouse. So that's already mature, established technology. And then there is a Serverless SQL pool. This is a little bit outdated illustration. While Synapse Analytics was still in public preview, Serverless SQL pool was called SQL On Demand pool. So in the meantime, it changed, but don't be confused. So SQL On Demand pool, basically it's Serverless SQL pool. That part of the architecture will be highlight of our today's talk. Then folks familiar with Python, Scala, or Spark SQL can leverage usage of Apache Spark pool for processing large volumes of data. When it comes to storage part, there are also a bunch of possible options to choose from, starting with traditional relational way of storing data in a SQL data warehouse, then also Spark tables, Azure Data Lake Storage Gen 2 Data Lake, all the way to non-relational document style storage mode in Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. And finally, you can quickly visualize your data using, for example, Power BI. And watch out, here is the key takeaway. You have all these tools under one roof, either natively, either as linked services. And you can build, manage, and deploy your end-to-end data solutions from within a web-based user interface called Synapse Studio. We will take a closer look to this tool later in the session, as we now need to lay some more theoretical background. As you may notice on the previous illustration, Synapse Analytics offers 3 different analytical pools for performing different computations over your data. 2 of them are SQL based, which means that you can use familiar T-SQL syntax for querying the data. Also, 2 of them are provisioned, a dedicated SQL pool and Apache Spark pool, which means that you need to set some kind of infrastructure in advance. And more important, that means that you will be charged not only for computing power, but also for the storage you are using. Again, before we dive deeper into a detailed overview of the Serverless SQL pool, let's take a look from our aeroplane on its architecture. The core component of Serverless SQL pool is distributed query processing engine called Polaris. This engine separates compute and state for cloud native execution. Polaris Engine runs, let me just zoom it a little bit. Polaris Engine runs here on control node. And this control node basically represents the brain of the whole architecture of Serverless SQL pool. Then this control node interacts with all the applications in order to optimize and coordinate distributed execution of the query. Control node then splits the query into the smaller chunks and forwards them down below to compute nodes for execution. And it also assigns set of files to be processed by each computed node. So instead of a query in traditional SQL Server environment, we have something we call task. And task is nothing else but a unit of distributed query execution, so part of a query, if it's easier for you to imagine like this. And last but not least, unlike in dedicated SQL pool, where you are in charge for defining computing power and how many compute nodes will be used, Serverless SQL pool scales automatically to support your data workload. In case you're interested to learn more about Polaris Engine itself, I provided a link to a white paper in the slides, so please feel free to refer to it and find out how it works under the hood. Okay, I promised in the beginning when I was introducing the agenda that we will try to answer to 3 key W's regarding Serverless SQL pool. What, why, and when. So let's start with what, and I will try to keep this as short as possible. Serverless SQL pool is essentially a distributed data processing system, or maybe it's better to say a query service that enables you to query data directly from the data lake using well-known T-SQL syntax. There is no any costs for the resources, storage, and so on. You will be charged only for the amount of data processed by running your queries. We will examine later what counts in the amount of data processed and how you can take control over it. At this moment, just keep in mind that Serverless SQL pool is a typical pay-per-query model. As I like to say when I explain this stuff, you can think of Serverless SQL pool as advanced polybase for guys coming from traditional SQL world, or cloud polybase. Underlying technologies are not quite the same, but use case scenarios are pretty much. In polybase, you don't have open row set function to perform ad hoc analysis, as everything is handled through external tables. But yes, in the end, you can think of Serverless SQL pool as polybase on steroids. Let's call it like this. Now, as we hopefully answered what is Serverless SQL pool, let's try to examine why you would consider using it. First and most important, you don't need to set up any kind of infrastructure or clusters to make this thing running. Once you create your Azure Synapse workspace, Serverless SQL pool will be created by default, and that means you can start querying your Azure Data Lake storage as soon as you create your workspace, and that significantly reduces time to analysis. As I already stressed, when you provision dedicated SQL pool or Apache Spark pool, you will pay not only for computing power required to satisfy your data workloads, but also for the data storage. Here with Serverless SQL pool, you pay $0 for the data storage. Finally, learning a new programming language just for querying data from the data lake can be daunting for many professionals, especially those coming from the SQL world. Therefore, one big benefit of Serverless SQL pool is the possibility to use well-known T-SQL syntax to retrieve the data directly from the, let's say, CSV or Parquet files, or even from the documents stored in Cosmos DB. Now, in full honesty, Serverless SQL pool, of course, is not a magic wand that will solve all your data requirements. So it's extremely important to understand in which scenarios you should consider using it. So let's try to answer our final W, when would you use Serverless SQL pool? First one, I need to gain quick insight into the data laying in my data lake. I want to see, let's say, maximum or minimum value within a column, or quickly identify some outliers. I will perform basic data exploration of the data stored in CSV, JSON, or Parquet files using Serverless SQL, and then based on insights I got, I can decide how to leverage this data for further analysis. Number two, I want to build a kind of relational abstraction layer on top of disparate data stored between, let's say, CSV files, or Cosmos DB, and relational database. This way, I can build a kind of a logical data warehouse without needing to physically move or transform data in classic ETL way. Next, I want to perform simple but at the same time scalable data transformation within data lake itself using the language I know, and that language is T-SQL. As I transform my data, it is quickly available for further digest, either by reporting tools like PowerBI, or for loading into a relational data store if necessary, like, for example, Azure SQL database or dedicated SQL pool. As I said, Serverless SQL endpoint is provided by default within every Azure Synapse workspace, and you can immediately start querying your data using either Synapse Studio or usual suspects, as I like to call them, SQL Server Management Studio and Azure Data Studio. So let me quickly show you how to connect to Serverless SQL endpoint from Synapse Studio and from SQL Server Management Studio. Okay, so here I am in my Synapse workspace, and here you can see that I have my Serverless SQL point here provided. That's the thing I will need when connected from external tools like SQL Server Management Studio or Azure Data Studio. Now I can open Synapse Studio directly from my Synapse workspace, and let's wait a few seconds. Once I'm in, the whole thing is here on the left-hand side, where you can see different tabs, and I can go to Data tab and see in my workspace I created one database so far. And as a linked services, you can add whatever you want. I added my Azure Data Lake storage. You can add Cosmos DB, you can add Power BI, you can add whole range of different services to support your data workloads. So if I expand my Azure Data Lake storage, I can see different files that are in there. And you see this data folder, and I have a bunch of CSV files, for example, here, and I can immediately start querying data from there. So I can do a right click on this CSV file, and I can choose new SQL script, select top 100 rows, and Synapse Studio will automatically generate the code for me. I can run it directly here from Synapse Studio, and you can see using this open row set function, basically we are performing ad hoc analysis over data coming from this CSV file. And you can see the portion of data from my CSV file. I can go here and use whole range of different SQL functions. I will explain later what is supported and what is not supported, but just keep in mind that you can start immediately querying data from your data lake storage using T-SQL. That's the key thing. From SQL Server Management Studio, I'm already connected, but I will walk you through the steps for connecting to your Synapse Serverless SQL endpoint. So if you click to connect database engine, and then you here to provide, here you need to provide your Serverless SQL endpoint and credentials for logging to this Serverless SQL endpoint, and basically that's it. So you can querying data from SQL Server Management Studio or Azure Data Studio. Okay, so we will go back later to these examples. The key reason why we are here today is to examine how to leverage usage of regular T-SQL syntax for querying data that is stored within data lake. So let's check which options are available when using T-SQL in synergy with Serverless SQL pool. If you take a look at database objects, here is the list of objects you can create within Serverless SQL pool. The first and most important, and one that you will use most frequently, are views. You can also create multiple different schemas, same as stored procedures. When it comes to user-defined functions, you can use inline table value functions. Additionally, you can create external tables, both regular external tables and Ctas. Finally, you can create statistics on your data in order to increase query performance. Things that are currently not supported are tables, both permanent and temporary tables, as Serverless SQL pool allows querying only external data which resides in Azure Data Lake storage. The next feature that's not supported, and that's really important to keep in mind, is caching of query result sets. That means whenever you execute the query, engine will go and scan exactly the same amount of data. So no matter if you run your query once or 15 times for one single query, each time this query will generate exactly the same costs. Keep that in mind. And this is the thing I like to emphasize when I'm reading SQL related blogs or watching videos. All folks, when they analyze execution plans, they talk about query costs, and you can often hear something like, this query will cost you 100 query bucks, this query will cost you 500 query bucks. Here, please forget about the query bucks. We are talking about real bucks, real money. So you would want to think twice before hitting this F5 button for no obvious reason. You probably already realized that Serverless SQL pool doesn't support any kind of data persistency in between data lake storage and query result set. Therefore, you can't create objects like materialized views, unlike in dedicated SQL pool where this kind of intermediate storage is possible. Finally, you can't rely on objects like indexes or table partitions. You can partition files using file path function, but that's a whole different story. There is no table partitioning in traditional way. If you're interested to find out more details about what is possible and what is still out of reach, I prepared some useful links for you, which I will share in the end. Okay, now let me walk you through what you can and can't do with T-SQL statements. A whole set of features, or let's say almost whole set of features for select statement is supported in Serverless SQL. You can also use explicit transactions on metadata objects and perform data export using Ctas statement. I forgot to explain in previous slide what is Ctas. Ctas stands for create external table as select, and you can think of it like select into in regular SQL Server. So it's kind of exporting data to writing select statements to export data to external table. Also, if you need to write cross-database queries, that's also supported. Whole set of T-SQL built-in functions, except those three you see on your screens: OpenXML, Open Data Source, and Open Query. Finally, data definition language statements are also available. So create, alter, and so on. You can write all this stuff in Serverless SQL. What you can't do, you can't use insert, update, and delete statements. You can't perform merge within your queries. Within select statement itself, there are few limitations. Namely, you can't use for XML match and predict functions. And also query hints are not supported. And finally, you can't combine data coming from system views with distributed data. Now let me show you where the Serverless SQL pool excels and how you can quick and easy combine a whole bunch of disparate data sources to perform data analysis without exposing real data source to end user. So I will go again to SQL Server Management Studio and let me show you what I have here. So I created a bunch of different views here. Let me show a definition of some of them. So for example, this one just retrieves data from CSV file that is stored in my Azure Data Lake storage. So here is the path to my CSV file. And here I provided some additional parameters to specify the format of the file and that I want to skip the header row. It's not so important. So basically this view retrieves data from CSV file stored in my Azure Data Lake storage. Then next one takes data from Parquet file, which is publicly available, provided by Microsoft. So you can provide, you can specify the path and create external data source within external resources. And I have this external data source called Yellow Taxi, and I'm referring to it in this T-SQL query. And basically I'm getting data from Parquet file, which is stored somewhere. Then I have third data source, which is a list of public holidays in USA, which comes sourced also from Parquet file, which is stored in third location. And finally, what I can do, I can combine all of those views in one single, let me show you just to find it. So here, so I can combine all these views within one single SQL statement. And then I can use this SQL statement to expose data to an end user. For example, in Power BI report, I don't need to import all of those views. My end user doesn't even need to know that data comes from CSV files or Parquet files or even Cosmos DB. You can also build a view over data stored in Cosmos DB containers. And you can combine all of these things in one SQL statement. And then you can expose final result set to your end user. So basically you're encapsulating all logic using T-SQL syntax. And yeah, looking into this, you will assume that these are normal tables, normal views, but in the background, this data coming from CSV or Parquet files. So that's the power of Serverless SQL pool. Okay, so fine. So far, we discussed what is possible, in which scenarios you would consider using Serverless SQL pool, but we still haven't explained how to get the best from this engine, or what are the best practices for your data workloads once you decide to use Serverless SQL pool. So let's start with the list of actions you should perform in order to maximize potential of Serverless SQL pool. First, default storage account and serverless endpoint are by default in the same geographical region. However, if you're accessing other storage accounts or Cosmos DB analytical storage, try to place your Serverless SQL endpoint and Azure storage accounts that you are targeting in the same location, the same geographical region. That will reduce the latency for the data's network transfer. Then, if possible, convert your CSV and JSON files to Parquet format. Parquet format compresses the data, and this consequentially leads to smaller memory footprint of these files compared to CSV. Additionally, Parquet is a columnar format and in many ways resembles to column store indexes in a traditional relational database. Because of that, Serverless SQL Engine can skip unnecessary columns when reading data from Parquet files, which is not the case with CSV. This will directly affect not just time and resources needed for processing the query, but will also reduce the cost of that query. Then built-in schema inference. That's a cool thing, cool feature. Built-in schema inference enables you to quickly query the data in data lake without knowing underlying schemas and data types. However, as every handy feature, this also comes with a cost. And the cost is that inferred data types are usually much larger than the actual data types. For example, Parquet files don't contain metadata about maximum character column length. And the inferred data type is always varchar 8000. So even if you have, for example, column that stores data about US state, which is always 2 characters, if you don't handle this with explicitly defining data type, it will be read as varchar 8000. So I will now show you how to check inferred data types and how to handle this appropriately. So I'm going again to SQL Server Management Studio, and here is the query that I'm using to check data types from my Parquet files. Oops, something was broken here.
Nikola, just a quick question that
we
got from somebody in the audience. In terms of profiles, all right, so obviously I know you mentioned, having a BI profile, but then, we're thinking about data scientists, data engineers, and also talking about data warehouses in general, because sometimes it's been mentioned in our community about, data lakes and now even data mesh. In terms of who's getting access to this and how their experiences might be, do you feel that there is a big difference depending on the profile, or that overall that these things would be understood and experienced in a similar way?
Well, from my perspective, the greatest, let's say the greatest benefit can for data engineers, because for them this simplifies the process of let's say pipelining the data or preparing the data in that way that they can skip some steps that were previously necessary. So after the data is being stored in Azure Data Lake, then whole different profiles that you mentioned can benefit from here. Data analysts can use things like I showed previously. They can use it for quickly querying data and preparing for further data analysis. Then data warehouse people can also get quick insight and then decide, okay, this query is, for example, ran pretty frequent. Let's go and materialize it and store it in Azure SQL database, or let's store it in a dedicated SQL pool in SQL Data Warehouse. Data scientists can also train models within Synapse, not serverless SQL pool strictly, but they can use Synapse to attach as a link service. They can use Azure Machine Learning Studio, for example. So in terms of serverless SQL pool, data scientists and machine learning engineers, not so much. But in terms of Azure Synapse ecosystem, let's call it, like whole package, definitely that they can definitely take advantage of it.
Okay, perfect. Thank you.
Yeah, no problem. Okay, something is broken here. I will not waste time to fix this now. Sorry about that. In any case, I will provide the query in the end. So all the files that I used during the session, so you can experiment on your own. Fine. Then also, as I already mentioned, you can't partition the tables, but you can partition your files. And that being said, you can instruct Serverless SQL to target only specific folders and files using file path and file name functions. This way, you can reduce not only the amount of data for scanning and processing, but also the real money costs, as less data will be processed. And one bonus tip when using file path and file name functions, always cast results of these functions to proper data type. then take advantage of using Ctas whenever you can. This is one of the most important features in Serverless SQL. Using Ctas, you can store frequently used queries to a new Parquet file, basically, and then use this single external table stored in Parquet file instead of referencing multiple underlying tables multiple times. So it's not a materialized view as we used to know in a regular database, but it's still some kind of materialization. And this materialization occurs within Parquet file that is stored in data lake. On top of that, as the Ctas generates Parquet file in the end, you will get statistics automatically created when you query this table for the first time. So you will gain performance improvement for all subsequent queries that target this same external table. Every do, as you might expect, has its counterpart in don't. So here is the list of things you should try to avoid or at least reduce to a minimum. When you are running queries on Serverless SQL Pool, carefully plan other workloads that target your storage account. Serverless SQL Pool has a built-in capacity to resolve this kind of issues. It will send requests to data lake at slower pace, but that will obviously affect the performance of your query. Again, avoid schema inference. I know that it sounds appealing to quickly get up and running without wasting time and effort to handle inferred data types, but you should definitely spend some time resolving inferred data types to appropriate ones. I assure you, you will reap the benefits later. So the thing I'm talking about is, let me show you once again, I will go back quickly here. As you can see here, using this with clause, I'm explicitly specifying data types that I want to use. So instead of having, for example, vendor ID was varchar 8000, I want to have integer because I know that this type is proper for data stored in my data source. So always handle infer data types using this with clause. Okay, you can also query without this, but then, yeah, as I said, it's not optimal. It's not optimal for your performance and for costs in the end. Then get rid of single large files. Instead, if you have one large file, try to split it into multiple smaller files using file name and file path functions to reduce the amount of data that needs to be scanned and processed. With that in mind, some recommendation is to keep your single CSV file size between 100 megabytes and 10 gigabytes. In the end of session, I'm also providing you with a link for best practices regarding Serverless SQL Pool. Don't worry. Fine. That's it. Here we are. Do you know where this picture come from? Remember Jerry Maguire?
Oh, yeah.
One of my favorite movies. Yeah.
Great movie.
Yeah.
Great movie.
And there's
a great line.
Yeah. And there is a great scene when Cuba Gooding Jr. asks Tom Cruise to scream on the phone, show me the money, but Tom Cruise doesn't scream enough passionately. So he asks him again, show me the money. So yeah, Jerry in the end screams, show me the money, show me the money. So remember this picture. It's what Microsoft will ask you to do. I'm kidding a little bit, but yeah.
Well, Microsoft and any provider out there. So.
Yeah. But in the end, yeah, I know that majority of you stayed till this point with me to hear how much will Serverless SQL cost them, and I don't blame you. That's why I've intentionally left this this topic for the later part of the session. So let's first examine what are you paying for when using Serverless SQL Pool. If you go to Microsoft documentation, you will find bold sentence that says you will be charged for the amount of data processed. That's fine. But let's dig deep and check what counts for the amount of data processed. The first thing is amount of data read. Here you should count data itself, but also amount of related metadata for formats that contains metadata like Parquet, for example. Then amount of moved data. What's this? When you run the query, it's being split. You remember the illustration from the beginning of the session. So your query is being split into smaller chunks and sent to multiple compute nodes down there for execution. And while the query runs, these intermediate results, so data is being transferred between the nodes. And these intermediate results is something you should be aware of, same as final data transfer to the endpoint in an uncompressed format. In reality, I will show you example. In reality, this number will differ if you run something like select star from the file that has 50 columns from the case when you are selecting only a few columns. I'll show you the difference, as I said, in a few minutes. And finally, amount of data written to data lake. This applies in those scenarios when you use Ctas to export query results to a Parquet file that's going to be stored in a data lake. So when you sum up these three items, you are getting the total amount of data processed. Also statistics, as in regular SQL databases, statistics will help the engine to come up with optimal execution plan. Statistics in Serverless SQL pool can be created both manually and automatically. And in both cases, there is a separate query running to return the column on which statistics is built on. And this query also has some amount of data processed. One important takeaway here is with Parquet files, when you create statistics, only the column where you create statistics, so only the relevant column is being read from the file. On the other hand, with CSV files, whole file needs to be read and parsed in order to create statistics, even for a single column. And going back to our original request for showing Microsoft the money, currently pricing starts from $5 for 1 terabyte of processed data. There is some promo periods until the end of July that first 10 terabytes of data are free of charge. So go and use this until the end of July. After that, you will be charged $5 per 1 terabyte. And
just to kind of go full circle, to go a little bit full circle with what you mentioned in the beginning, because when we're talking about data nowadays, as opposed to 15 years ago, you're mentioning, size and then also sources, and you very much covered this. When you mention these costs, how many terabytes of data are we going to be thinking about? Because, $5 doesn't sound that, I can do $5, but on an organization level, in terms of amounts of data that are being managed, what kind of numbers do you see frequently?
It depends. It depends. But I would say that Serverless SQL is the nice solution for some ad hoc things, and it's not expensive, really not expensive. But I saw a few cases, not so many, fortunately not so many, but I saw a few cases where basically what people did, they created the reporting solutions based on direct query over using Serverless SQL pool over Azure Data Lake. And there were hundreds of queries generated targeting this underlying data. And because there is no kind of caching anywhere, so each time query goes and scans exactly the same amount of data. And for example, it scans 2 gigs of data every time. So if you have like 100 queries per day, it's 200 gigs for 1 day. And if you multiply this by 30 days, or even if you multiply with multiple reports, multiple users, I saw cases that there was few $100, which is still not so painful.
No,
but yeah, it's a sign to be just to be cautious. Yeah.
But like you said, and that's where things like monitoring metrics and just basic due diligence are going to come in.
Exactly.
With that in mind, because we got a follow-up question on that, which is the most expensive part of non-serverless data query approaches, traditionally speaking?
The most expensive. So, for example, if you're using like dedicated SQL, where you are paying, that's a good question, because I don't have, like straightforward answer.
No, don't worry. No, we can get to that later in Slack. That's fine. Anyway, keep going.
Yeah. Okay. Yeah, we can discuss it later. Yeah, it's a good topic. Definitely, it's a good topic. Other than that, keep in mind that minimum chargeable amount per query is 10 megabytes. So even though you sometimes have a query that processed less than 10 megabytes of data, you will be charged as this minimum threshold was reached. Now I want to show you different scenarios when querying CSV versus Parquet files, and also difference between select star and selecting only a few columns. So I already prepared here some nice examples. Let me show you first CSV file where I'm selecting only 3 columns. So I'm returning only those 3 columns. And I ran this query. You can see that it returned around 7.6 million rows. And if we go to Messages tab, I can see that total size of data scanned is 755 megabytes. Total size of data moved is 62 megabytes. Just remember this number. And total size of data written, as we didn't export anything, is 0, of course. So total amount of data processed, the thing you will pay in the end, is the sum of these 3. This one, and this one. So this query costs 870 megabytes in megabytes. We will later turn that into real dollars. Mm-hmm. Now if we go to CSV and just run select star from this exactly the same file, so you see the number of rows is exactly the same. And if we go to messages, you see that total size of data scanned is again the same. So again, engine scanned the whole CSV file, but this time amount of data moved is 10 times bigger. Just keep that in mind. This CSV file is small, doesn't have a lot of data. But if you're working with larger files, or if you are querying this file multiple times, each time it will generate 10 times more in terms of data processed. So keep that in mind. If you don't need all columns, don't run select star. It's a bad practice. Like in normal SQL, it's a bad practice here too. Now for Parquet file, because I explained that Parquet stores data completely different than CSV. If I run this exactly the same query over my Parquet file and return exactly these 3 same columns, you see the number of rows is the same. And if I go to messages, you will see that now total size of data scanned is only 79 megabytes. Data moved is 146. Why is this so small? Because engine was able to eliminate all unnecessary columns. So it scanned only those columns that we specify in select statement. And finally, I have select star over Parquet, which return same number of rows. And here, now you see that this amount of data scanned is like 3 times bigger, but the total size of data moved is significantly bigger than in our previous example. Why is that? Because Parquet also stores metadata. So these are queries that are run to retrieve metadata from Parquet file. Again, don't use select star if you don't need to. That's the key takeaway from this story. Okay, so here is the short overview of different conclusions that we can draw between CSV and Parquet. With CSVs, data scanned is exactly the same in every scenario. Either you run select star or either you run select, just give me my 3 columns. For Parquet files, is different amount of data scanned and data moved, and you can compare the difference between different scenarios that I've just demonstrated in SQL Server Management Studio. So let's now go through the list of the items that goes on house, or if you prefer, that Microsoft will not charge you for. So what doesn't count as amount of data processed? Querying server level metadata, stuff like roles, logins, server level credentials. Databases you create within your serverless SQL endpoint, as these databases don't contain real data, they contain only metadata like schemas, views, store procedures, external file formats, and so on. Then metadata related queries, because they don't process data from the storage. And finally, data definition language statements, except create statistics, because I explained that when you create statistics, there is some amount of data processed while statistics is being created. Fine. So up until few months ago, while Synapse Analytics was still not generally available, finding out how much a specific query cost was, well, quite cumbersome task. There was no way to find data about the completed queries, only those that were in progress. But let's not look back, and let's talk about current state of affair regarding cost control in Serverless SQL pool. The first and most important feature is that you can set the maximum threshold for amount of data processed. The number you define is in terabytes, just for you to be aware, and you can define the maximum amount of data processed on daily, weekly, or monthly level. How it's done? You can do this either through user interface in Synapse Studio or executing T-SQL statements in SQL Server Management Studio. I will show you now both ways to perform this. If I go to my Synapse workspace, and I'm in Synapse Studio now, if we go to Manage tab here on the left, and here you see this built-in, this is Serverless SQL pool, and this small icon here showing me some kind of money or something like that. If I click on it on the right-hand side, I can see the current amount of data processed for today, this week, and this month. And here I can set my limits for daily, on a day level, week level, and month level. So let's check here. For example, I'll put 300 and apply this. And you can also, as I said, do this from SQL Server Management Studio. So if I go here and let's check first current limits from sys.configurations. So I can see that daily limit is 10, weekly limit 20, and monthly is 300, as I previously set the new value. And I can also run those stored procedures to change the current limit. So let's revert monthly limit to 100. I will execute this SPS set data process limit procedure. And if I check again, you will see that my limit is now 100 again. Here is the short query that check current amount of data processed, and the last column shows you how much money you will need to show to Microsoft. So if I run this query, I can see the amount of data processed in megabytes, gigabytes, and terabytes for this day, week, and month. And Bart, you asked me, so in terabytes, I processed today, you see 0.003440 terabytes.
And it was a very good day.
Yeah, that will cost me. Yeah, for you, this session is free. For me, it's not. So I'll need to pay this money in the end. Yeah, just kidding. Of course,
send us the bill. Send us the invoice. We'll show you.
Okay, yeah, yeah. But basically, you can calculate. You quickly calculate how much real money.
But I think that's a really good point, though, too, because a lot of times, and like you said, it's funny how some people really just focus on the cost factor, but it's true, and that's also, you know, with cloud adoption, a lot of times this gets totally overwhelming, and so then people start pointing the finger at the service provider, saying, "Oh, it's Microsoft or Google or IBM or whoever." But I think these things can be done in a responsible way. We generally hear the horror stories of companies that get hit with really, really big bills. Sometimes it's maybe not asking the right questions. Another thing we say as well, too, one thing is the technology, another thing is the culture and the mindset. There are other things that factor in there, but it's really nice to see a demo that does have a cost attached to it so that we're putting these things in real terms.
Exactly. And it has specific use cases, really. So if you stick to this, and yeah, then you're good to go, definitely, with the costs also. Fine, so I guess there was a lot of information to absorb in less than an hour. I mean, we covered a whole range of different topics, from traditional versus modern data warehousing, Synapse Analytics architecture, all the way to best practices for serverless SQL and cost control. And we even talked about Jerry Maguire. Remember that?
Let's not forget Jerry Maguire.
Yeah, it's completely fine if you're still not sure whether a serverless SQL pool is the proper answer to your analytical workloads or not. Therefore, I prepared a list of useful resources, I think useful resources, that you can always refer to and find answers to. Well, if not to all, let's hope most of your questions. So, of course, feel free to ping me or get in touch in case that you need any further clarification on if you think that I can help in any other way. or if you just want to talk about Synapse Analytics, I'm a big fan of it.
Clearly, no, there's no doubt about that.
Yep.
Really quick with that, just because we don't have a ton of time, but as a person who's been working with data for the last 15 years, also blogging, sharing your knowledge, working as a teacher with Pluralsight. In your particular case, what's worked the best for you along your learning journey? Because I understand, when we talk about, single sources of truth, is there one place where you can go to get all your data information? Is there one blog? Is there one set of videos? Generally not. But in your personal experience, what's worked best for you in terms of learning and growing as a data professional?
Yeah, for me, I like books, like, for example, traditional books. And I have full shelf of different books, starting from Kimball's, to all the way now to DEX, Definitive Guide to DEX for Power BI on storytelling with data. So anything that has some kind of relation to data. So I'm a fan of books. Also, try to watch videos, but it's hard to stay on track and to keep the pace, because there are a lot of really great resources, so it's hard to focus on some specific and find. But for someone, videos works best. For someone, video courses. For someone, blogs, as you said. For me, books. Definitely books.
No, that's good, because like you said, people learn in different ways. Some people are more visual learners. Some people like to listen. Some people really need things that are hands-on. I think what happens though for a lot of people is, like you said, because there are so many resources, it gives folks a sensation sometimes that you have to be consuming everything and try to say, like, look, it's not, no, calm down.
Exactly.
You can,
exactly.
I think it's just, the main thing is discipline and being constant and consistent. So anyway, that's great advice there too. One last thing, could you stop sharing your screen so I can share mine?
Sure.
Because while you've been talking, we have a wonderful tradition in our community where we have our own in-house visual specialists. So when we're talking about, visualization, things like that, can you, okay, good. All right. So I'm going to share my screen. Let's see, you should be able to see it soon. Let me know if you can see it. Can you see it?
Not yet. Yes, I can see it now.
Okay, very good. So while you've been talking, our good friend Angel has been in the background, and he's been drawing the things
That's awesome.
Obviously, it's challenging for him because you're talking about, there's a lot of different things that were covered, but this is and just to make everything very clear, I'm very grateful that Angel indicated on the ninja's leg that that's the ninja, so that there's no text there. But anyway, so we got a little bit of Barca, we got a little bit of football, and we got our ninjas in there as well too. The Swiss Army knife behind the ninja, I think that's a very nice touch as well.
That's awesome. That's awesome.
So we try to, like I said, we try to have a diverse amount of different ways of presenting information. You shared some great links in there. If we can get you to share the slides, you can share them with me, and we'll get those in our Slack. And we'll also have them in the video description for when folks see this on YouTube. Nikola, thank you very much. I got in the back of my head an idea that we could do maybe a meetup in the future about how these data processes with analytics, with statistics, with warehousing, with pipelines can be applied to something like Barcelona, your favorite football club, because it's, once again, it's about the data, but it's also then the insights, how we're going to be taking decisions based on the information we're getting. And I think applying that to something like football could be extreme to soccer.
Perfectly said. Perfectly said. You gave me a great idea. Yeah, you gave me a great idea.
No. I think that would be a great blog post. And obviously you get to combine two things that you're very passionate about.
Exactly.
So anyway, it was wonderful having you today. How do we say goodbye in Serbian, since I only got as far as hello?
You can say again, zdravo, ciao, doviđenja.
Doviđenja, that's nice.
Doviđenja is goodbye, yeah.
Okay, doviđenja, I like that a lot. Anyway, thank you very, very much, Nikola. It was a pleasure to have you. We'll definitely be having you again. Everybody, if you're not already checking out Data Mozart blog, you got to get on there. I shared the link in YouTube. We'll be sharing it again in social media when we post all this stuff. Have a wonderful day, and thank you so much.
Thank you. Thanks for having me, and thanks to all who attended the session. Yeah, I really enjoyed it, and wish you all the best. See you again, definitely.
Likewise. We'll continue the conversation in Slack, okay? Thanks very much, Nikola. All right.
Bye-bye. Thank you. Ciao.
Oh.